Hello viewers, I'm Kausalya. Today we are going to solve problem number 9 under the topic Bode plot. The problem is draw the Bode plot of the open loop transfer function. So this is our given function, right? So the first step is when you look at the problem, you see the standard format should be, we should be having 1 plus some number along with s, right? But here you see we are having s, that is coefficient of s is 1. In all the cases we are having simply s here, right? So we have to modify our given problem. So the first step is we are going to take the constants outside from each expression. So from this s plus 10, we are going to take this 10 outside, and here in this s plus 5, I am going to take this 5 outside, and this s plus 20, I am going to take this 20 outside, right? So here I had taken the numbers outside. So after taking out the numbers, when you cancel, finally we are getting an expression as like this, right? So you see, when you take 10 outside, what happens? S by 10 plus 1, right? So this S by 10 is written as, we can write it as 0.1 S. Similarly here, when you take 5 outside, we will be having S by 5 plus 1. And again, when you take 20 outside, here you will be having S by 20 plus 1. So when you solve these expressions, here we are having like this, right? And the next step is, here we are going to substitute s as j omega. When you substitute s as j omega, the equation gets modified as like this, right? So this is our final expression. So from this expression, we are going to find the values for magnitude plot as well as for the phase plot. So for calculating magnitude plot, what is the basic step? We have to calculate the corner frequencies, right? So to find the corner frequency, the thing is you have to take reciprocal of the coefficient of omega. So here coefficient of omega is 0.1, right? So 1 divided by 0.1 is 10. And again here the coefficient is 0.2. So 1 divided by 0.2 is 5 here. And another one is 0.05. So when you take reciprocal of this, here we are getting 20 radian per second, right? So first find out the values. After finding out the values, then you have to give the number. The least value should be given as 1. That is, this is your first corner frequency. The term next higher to 5 is 10 here. So here I had written omega C2. And the next higher term is 20. So here I had written as omega C3, right? Only based upon the values of corner frequency, we have to order them, right? So the next thing is, we are going to form a table, right? So our table consists of 4 columns: terms, corner frequency, slope, and change of slope. So here from this problem, while arranging the terms, the first priority should be given to constant along with omega, that is individual omega. So here you see I am having 20 by omega, right? So this 20 by j omega, I have to write it first. Then after writing this, we have to arrange the terms based upon the ascending order of corner frequency. So here you see I had first listed out the corner frequencies: 5, 10 and 20. So which term contributes 5? It is contributed by this term, right? By this terms, and this term lies in denominator. So here I had written as 1 divided by 1 plus 0.2 j omega. And the next thing is 10. Which term contributes the corner frequency of 10? It is contributed by this term. So it lies in the numerator. So here I had simply written as 1 plus 0.1 j omega. And finally 20, the 20 is produced by this term, and again this term lies in the denominator. So here I had written as 1 divided by 1 plus 0.05 j omega, right? So after writing the corner frequency, now we are moving to the slope, right? So a constant and omega will never produce a corner frequency, so here it is nil. So an omega in the denominator, it produces a slope of minus 20, right? That is omega produces 20 decibel per decade. Since omega lies in denominator, this produces minus 20. Right. Similarly, here also omega term lies in denominator. So here it produces minus 20. But here you see our omega lies in the numerator part. So what is the value of slope it provides? It provides a slope of plus 20. Right. And here again we are having an omega term that lies in denominator. So this produces a slope of minus 20. Right. Then we are going to the change of slope. Again then this term will never produce any change of slope. So here it is nil. And the next thing is, you see, we have to shift this minus 20 downwards and we have to move this minus 20 to the right hand side. Right. So what happens? Minus 20 and minus 20 gives you minus 40. And the next step is, again we are shifting this minus 40 downwards and I am moving this plus 20 to the right hand side. So what happens? Minus 40 plus 20 gives you minus 20. Again I am going to shift this minus 20 downwards and again I am going to move this minus 20 to the right hand side. So what happens? Minus 20 gives you minus 40. Right. So we have completed the table now. The next thing is we have to select two values of frequencies, right? One is a low frequency, that is its value should be less than your first corner frequency. And another one is omega h, whose value should be greater than your higher frequency, that is highermost frequency. Here our highermost frequency is omega c3, right? It is 20. So you have to select a value which is greater than 20 here. That is you will be your omega h, right? The next thing is, here I had selected omega L as 0.1 and omega h as 100, right? Now we are going to find the magnitude for all these frequencies. So here we are representing the magnitude as A here. So A is nothing but mod of j omega in dB, that is in decibel. So at omega equal to omega L, the magnitude is always given by, that is magnitude is in dB. So we are including 20 log and this initial values of magnitude is given by constant with individual s, right? So here when you observe the problem, here we are having constant as 20 and the individual omega, that is j omega term. So just substitute the values here. So 20 log of 20 by j omega, right? So what is the value of omega? We have taken omega L as 0.1. So just substitute the values and find out. We are getting 46.022 decibel, right? At omega equal to omega C1. So during this, A is given by 20 log of 20 by j omega. So what is the value of your omega C1? Its omega C1 value is 5, right? So just substitute the value and calculate. You are getting the value as 12.04 dB, right? The next is at omega equal to omega C2, the value of A is given as change of slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus the value of A when omega equal to omega C1, right? Because from omega C1 to omega C2 there is a change of slope. Do you people accept that? It is clear from the table. Whereas for omega C1 there is no change of slope because it is your first corner frequency. That is the reason why we are using this formula for this omega C2, omega C3 and omega H, right? So here change of slope from omega C1 to omega C2, we have to look at our table. So this is our omega C1 and this is our omega C2. So from omega C1 to omega C2, what is the change of slope? It is minus 40, right? Because this minus 40 is contributed here. So the value is minus 40. So here just substitute the values. So minus 40 into log of our omega C2 is 10 and omega C1 is 5. Plus the value of A when omega equal to omega C1. We have to look back again. You see, at omega equal to omega C1, what is the value of A? It is 12.04. So just substitute the values here and finally the answer is found to be 0 dB, right? Now we are moving to the next corner frequency. So here the formula is again change of slope from omega C2 to omega C3 into log of omega C3 by omega C2 plus the value of A when omega equal to omega C2, right? So change of slope, again we have to look back at our table. So this is our omega C2, right? And this is our omega C3. So from omega C2 to omega C3, what is the change of slope? It is minus 20. You see this minus 20 is given here. So minus 20 is the value. So minus 20 into log of omega C3 is 20 and omega C2 is 10, right? Plus the value of A when omega equal to omega C2. It is just our previous value. You see omega equal to omega C2, the value of A is 0. So just substitute the values here and finally you are getting the answer as minus 6.02, right? And the next thing is at omega equal to omega h. So again the formula is change of slope from omega C3 to omega h into log of omega h by omega C3 plus again the value of A when omega equal to omega C3. So here in this case, change of slope from omega C3 to omega h, again you have to look back. So this is my omega C3, right? So from omega C3 to what is omega h? It is 100, right? So 100 will be only written after this 20. So what is the value of slope? This minus 40 will be contributed here, right? So the value is minus 40. So just substitute the value. So minus 40 into log of omega h is 100 and omega C3 is 20 plus again the value of magnitude is, that is the previous value, right? It is minus 6.02. So just substitute it here and finally we are getting the answer as minus 34 dB, right? So here finally I had listed out the values of different frequencies and their respective magnitude, right? So here I stop my video. Let us consider this as part 1 and part 2 will be continued later. Hope you people understand well. Thanks for watching.